Hello and welcome back to Calculus 3. Tonight on the menu, 13.4 triple integrals. Progression from 1 to 2 to 3 integrals. How many can we stock? As many as we want, mathematically. However, application-wise, 3 is where we stop, because with triple integral, you can either compute the volume or you can compute the fourth dimension known as bulk. So I can compute the volume if I have the triple integral over some region D and just dv. Then each integral with its dx, dy, dz brings one dimension to the table, and we have a 3D case. Or we can have a triple integral over region D where you have some function in there, which would bring us into the fourth dimension, because again 3 integrals dx, dy, dz will bring 3 Spartal dimensions, and then you might have temperature or density or something inside the integral, which we are going to use in our tomorrow for the central mass. So tonight we are focusing on 3 different triple integrals. We are going to talk about rectangular triple integrals first, which is dx, dy, dz, or in any of the other 6 possible ways. And then we are going to, in the next section, focus on cylindrical and spherical triple integrals, and which are both upgrades to the polar coordinates. So to start with the triple integrals today, we are now not thinking about representative rectangle, representative pizza slice. Now we are thinking about representative cube. So you are going to think of the little ice cube that melted to infinite decimal, being infinitely small, and you want to stack as much of those as you can in the object to fill out the space, to fill out the volume. Since we have dx, dy, dz, multiply those 3 together, well, using integration now, and we are going to have the volume. So the first order of business is to work on volume on the box. So say you have a box, just like the one that we are sitting in right now, which has x, y, and z, and say that you set the coordinate system x, y, and z that will help you with understanding the box. So now when you look at this, let's say that's 5, that's 2, and that's 3. The vanilla, let's call it like that, which is a rectangular triple integral, right? The most basic one would have all the numbers in their limits, just like the double integral over general, or not over general region, over rectangular region. So to find the volume of this box, I simply stack up 3 integrals and put these in any order that I want to, and say the inner integral is x, x goes from 0 to 5, the middle integral is y, y goes from 0 to 2, and the outer integral is z, z goes from 0 to 3, So I call this vanilla because it's just plain and easy and simple. So now you have 0, 0, 3, 2. I fear it's time for update, which means half of the class gone. What happened? Oh.
Oh yeah, an ad came up and
Beautiful. Yeah. My allergies on this are kicking in now. Restart for the 50th time. Yeah, give it some time. Alright, let's see if it works now. There we go. Does anyone have an Apple device? I just need to break something so I can. Any sort. I don't care what it is.
I don't even know you anymore.
The first thing, the last one you left.
What?
It's on the screen too, buddy.
Yeah.
No, you want the break.
Oh,
Yeah, to just release stress and anxiety and anger. I don't want to ruin anything valuable. So let's.
come on.
Maybe we'll see. Yeah, I don't know. It works great on Windows 8.1. This one is constantly crashing. It's supposed to work better on it. I guess not. Alright. Looks like it's gonna work now. So again, just like double integrals, we work the middle one first, then we integrate again the inner one. So that's gonna be now 10. And then we integrate this one out. And finally get 30, which we could have done earlier. 5 times 2 is 10, times 3 is 30 for the box. But this is just in case someone asks you why, right? So now you know why. How do we make this more interesting? We get planes and surfaces and shapes all over the place. And they end up in limits of the integrals. And then you keep integrating and integrating and integrating.